Hello, everyone. So, the next concept is methods of computing average rainfall. So, there are various methods of calculating the average rainfall because at the end of the day, we need to calculate how much is the total average rainfall of that particular day or that particular month or that particular year as such. So, it is all done by approximation. Okay, so throughout the year the rainfall will not be same, so it is very uncertain. So that's why in order to uh, calculate the average rainfall we have three methods as such. And the catchment area, now for example, we want to divide this. The catchment area is divided into various parts and the rain gauge stations are established at every part. And the small area, so for example the small area is less than 50 kilometer square, so single point rainfall may be taken as an average depth over a area. So if it is falling at one single point only, that single point rainfall can be taken as the average depth. But for larger areas average depth rainfall values is over a if you the area is more, then we have to categorize it into a different methods. And whatever average rainfall which falls over that particular basin has to be worked out. So there are basically three methods to calculate this. One is arithmetic average method, then is the Thesian polygon method, and the third one is isohydral method. So first is the arithmetic method. It's also called as average method. In this, basically this is the simplest method to calculate the average depth of the rainfall. That is the it is the sum of all the depth of rainfall measured at every particular stations. For example, P1, P2, P3, and so on up to N. If this is the average depth of rainfall, which is measured at the different stations, that is station 1, 2, and 3, and so on up to N respectively. Then the average depth of the rainfall can be calculated by P is equal to P1 plus P2 plus P3 and so on up to Pn divided by n, where n is the number of stations, that is number of rain gauge stations. So this is the average depth of the rainfall. Okay, P is nothing but average depth of rainfall, can be collected by using uh, depth of the rainfall at every station. So station 1, 2, and 3, and so on up to nth station divided by total number of stations. So this is called as the arithmetic mean method. So it is the simplest method. So the important features of this method is, so first thing is the simplest method, and then it is suitable if rain gauge stations are distributed uniformly throughout the areas and rainfall variation is not very large. And it is used for determine approximate rainfall. And the most important method, it is the rapid method to calculate the average depth of the rainfall. So this is called as the arithmetic mean method, or it's called average method. So the next method is Thesian polygon or Thesian mean method. So again, in this method, it takes into account the non-uniform distribution of rain gauges by assigning a weightage of each rain gauge. So basically, it is like a polygon. You can see here. Um, so this is a catchment area. The catchment area looks like a polygon. So it is again divided into four. So the catchment area is divided into A1, A2, A3, and A4. A4 areas, and so it is completely distributed like this, and then it is made into a polygons as such. Okay, you can see here this is A1, A2, A3, and A4. Okay, now in this method the adjacent stations are joined by straight lines through dividing entire area into the series of triangles. So the complete area is divided into a series of triangles. You can see here A1, A2, A3, and A4. The center line is marked here and it is divided into the triangle. You can see here. So 1, 2, and 3 area. Okay. A1, A2, A3 is again a triangle, A4. Okay. Now, the perpendicular bisectors are erected from each of these lines to form a series of polygons known as Thesian polygons, such that each polygon contain one rage gauge station. You can see here from this line, one perpendicular line, from this another. So this is A1. So this is one station. Similarly, another perpendicular line, perpendicular line. These are called perpendicular bisectors. Okay. Then from this line, A3 from this line, and A4 is perpendicular from these two lines. Okay. So A1, A2, and E3 are all marked. And these are called as Thesian's polygons. So there it becomes a polygon. So A1, A2, A3, they are completely joined together and they are called as a polygon, the dotted lines. Okay. So if P1, P2, P3 are the rainfalls at individual stations and A1, A2, A3 are areas of the polygons, then the surrounding areas of polygons surrounding the Artesian stations respectively, then the average depth of rainfall. So if you want to calculate the Thesian uh, method, then so average depth of the rainfall using Thesian's method is A1 P1 plus A2 P2 plus A3 P3 and so on divided by total area of the basin. Okay, so it's all dependent on the, so average depth of the rainfall is dependent on the areas here. Okay, so it is dependent on the areas of the respective polygon. So P1 is nothing but with respect to A1. P2 is with respect to A2 area. P3 is with respect to A3 area. So divided by total. Okay, so the salient features of this method is it is superior to arithmetic average method as weightage is given to various stations. So every station you have the areas there. And rain gauge stations outside catchment area also can be used effectively. So it is because it is not restricted to only the station, but it is with respect to the areas as such. Okay. Then new Thesian polygon diagram is to be drawn at every time for catchment. New Thesian polygon diagram is to be drawn for every time for catchment if there is a change in the gauge network. So it can be changed as and when it is required. Okay, so it is main important thing about this method is it gives information of the precipitation with respect to the area. So that's why it is more efficient and superior to the arithmetic mean method. Okay, the last one is the isohydral method. So in the isohydral method, so basically isohyds are lines which are drawn on the map passing through places having equal amount of rainfall recorded during the same period at same places. Okay, so you can see here these are isohyds. These vertical lines on the map, they are isohyds, which have the same amount of rainfall. So this is 20, 40, 60, 80, 100 and 120 mm. So these are these vertical lines on the map are called as isohyds. So isohydral is a contour of equal rainfall, and from isoheight of a place, it is possible to get an idea of average rainfall at any place. So with the help of this rainfall record of various stations in the catchment, isoheight map is drawn, and the area between the isoheights is estimated on a graph paper with the help of a planimeter. So here you can see here this area you can divide this. Hmm. So this is A1, A2, A3, A4, and this is A5. Hmm. So this is done using a planimeter. Hmm. So if you want to know the average depth of the rainfall, P, average depth of the rainfall, P, for an entire area A, it is given by P is equal to 1 divided by A. A is the total area into summation of area between two adjacent isoheights into mean of the two adjacent isoheight values. Okay, for example, the meaning of this is so it is A1. Okay, area between the two adjacent isoheights A1, then mean of the two adjacent isoheight values, so it is P1 plus P2 divided by 2 plus A2. So it's basically again area into its p value. But here, what we'll take if you want to take A1, so adjacent is P2, second area. So it is P1. Okay, if you want to see here, okay, if I want to find this area of A1, So it is A1 into P1 plus P2, that is 120 plus 100 divided by 2. Similarly, A2, if you want to find A2, it is A2 into P2 plus P3 divided by 2, and so on, divided by total area A of the catchment. Okay. Then the most important salient features of this is the most accurate method but requires experienced analyst. So it is more suitably for hilly areas because there you have a different iso heights, and it gives reasonable accurate indication of rainfall distribution. Okay. So this is the most accurate method to calculate all the average rainfall of any given area. Okay. After this, we have optimum. So it's called as adequacy or optimum number of rain gauge stations. So how to calculate this? Like how many rain gauges has to be installed and at what distance and what spacing. So all this is discussed here. So here we use statistics to determine the optimum number of rain gauge which has to be installed, and it has to be in such a way that certain number of rain gauges required stations are necessary to give average rainfall with certain percentage of error. So everything has a percentage of error, so this percentage of error should be as low as possible. So if the allowable percentage of error is more, then lesser number of rain gauge station would be required. Mm. And based on the statistical principle, optimum number of the rain gauge n can be obtained by the following equations. So we have the equations here is n is equal to CV divided by E the whole square, where n is the optimum number of stations, rain gauge station. Capital N is the optimum number of rain gauge station, and CV is coefficient of variation of rainfall values. Okay, so coefficient of variation of rainfall values. E is the allowable percentage error in estimating mean rainfall. So optimum number of rain gauge, coefficient of variation of rainfall values, E is the allowable percentage error. So now CV can be computed. Now how to calculate the CV, that is coefficient of variation of rainfall, can be calculated by using the formula. So P dash is equal to summation P divided by N. Again, when small n is the number of rain gauge station, hmm, number of rain gauge station existing. Okay. Mm, capital N is the optimum number of stations. N is the total number of rain gauge station which are existing, and summation P is the total annual rainfall. So P dash is equal to summation P by N. Mm, and the allowable degree of error is taken as 10%. So capital E allowable error is 10%. And so now we have this formula to calculate CV, that is coefficient of variation of rainfall, is equal to sigma m minus 1 divided by P average into 100, where sigma m is standard deviation. Okay, standard deviation divided by average rainfall. Okay, so as of now, it is good to understand the formula. We'll be solving problem on then it becomes easy to understand. Okay, all right, that's all for today. Thank you.